the new topic, that is calculation involving unit cell dimension. Calculation involving unit cell dimension. Let us know it. We know what is the density. Density is equals to mass upon mass. If we are discussing the density of unit cell, it is equals to mass of unit cell by the mass volume of unit cell. You know what is the volume of unit cell? The first one is volume of unit cell. It is equals to A cube, where A is edge length of unit cell, volume. So the next one we will know what is the mass of unit cell. The next one, mass of unit cell is equals to Z into M, where Z is number of atom in a unit cell. As we know, the Z in case of simple cubic is 1. The Z in case of body center is 2. The Z in case of face center is 4. It means the Z, or the number of atom in different unit cell, simple cubic, body center and face center, is different. To the next, what is M? M is the mass of single atom, or you can say sphere. Can we relate the mass of an atom with its molecular mass? Yes, let us see. We know M, which is mass of an atom, it is equals to the molecular mass, capital M, by Avogadro number, Na, where M is molecular mass and Na is Avogadro's number. You know, we have studied how it is obtained. We know that the molecular mass contains a number of atoms. Clear? It means, therefore, molecular mass contains n number of atoms. Therefore, the number of, what we can say, the mass of one atom is equals to molecular mass by m by n a. What we have obtained? We have obtained what? The mass of unit cell. It means it is equals to the number of atom into mass of unit cell equal to number of atom into mass of one atom. We know the mass of one atom is m by Na, where m is molecular mass and Na is Avogadro number. From where we have obtained it? We know if we are discussing about the oxygen, it means 16 gram, that is the molecular mass of oxygen. It contains what? 1 mole of atom. It means 6.022 into 10 to the power 23 atom. It means the mass of 6.022 into 10 to the power 23 atom is 16 in case of oxygen. If you want to get the mass of one atom, what we do? We divide the molecular mass by Avogadro number, which we see here. Let us put these values into this. What we got? We got density of unit cell. Density of unit cell. Density of unit cell. Density of unit cell is equals to mass upon mass of unit cell, where mass of unit cell is Z into M. Z into M by A. Or we can say Z, or we can say this is also equals to, or this is also equals to Z into M is equals to capital M by Na. Capital M by Na into A. This is how we know density of unit cell is equals to Z into capital M by Na into A. What we know here? The density of unit cell or the element is equals to Z. Z means the number of atom per unit cell. Capital M, it is the molecular mass of that particular element. Na is the Avogadro number and EQ is the edge length of unit cell. This is how you can calculate, you can relate the density together with the number of atom in the unit cell, with the molecular mass, with the Avogadro number and the edge length of the unit cell. Let us discuss the next topic, that is imperfection in science. Imperfection in Let us discuss. We have discussed the crystalline and amorphous substances. What we have discussed? In case of crystalline substances, they have a regular arrangement of atom, whereas amorphous, they have not a regular or a definite arrangement of atom. Let us discuss the crystalline substances. It means in crystalline substances, the atoms are arranged in a regular manner, in a different pattern into the entire three-dimensional sphere. But can we think that they have a regular pattern throughout the network? No. That's why we have called them, they have long range order. It means that crystalline substance also contains some imperfections in them. They are not absolutely crystalline. They have not absolutely regular arrangement of atom. It means they have some imperfections. And this imperfection arises in crystalline substances due to fast cooling or moderate cooling. It means what we know? We know that the first point, the crystalline substances substances also contain imperfection in them. Therefore, they are termed as what? Having long range order. Long range order. We have also discussed that this imperfection arises in crystalline substances due to moderate or rapid cooling. Why it is so? Because during moderate or rapid cooling, the atoms does not get enough time to arrange properly in the crystalline lattice. That's why it develops certain imperfection. That means the next point is that this imperfection arises in crystalline substances due to what? Due to moderate or rapid cooling. Because on rapid cooling, the molecules or the atoms or the molecules does not get enough time to arrange properly in three-dimensional space. Let us discuss imperfections in crystalline solid. Imperfection or it is also termed as defect. This imperfection is of two types. The first one is known as cytometric. And the next one is known as imperfection or defect. It is of two types. The first one is known as point defect, and the next one is known as line defect. So the next, this point defect is categorized into two types. The first is known as cytometric. Defect, and the next is known as non-cytometric. And the next is known as what? Cytometric defect, non-cytometric defect, and impurity defect. The cytometric defect, based on the type of solid whether they are cytometric defect is of two types. The first one, in case of non-molecular solid, and the next one in molecular solid, and the next one is known as ionic solid. In case of molecular solids, they are categorized into two. The first one is known as vacancy defect. In case of ionic solid, it is categorized into two types. The first one is known as Frankel. Defect. The next is known as Soft defect. Frankel defect is also known as dislocation defect. In case of non-cytometric defect, it is of two types. What are the two types? Cytometric defect is of two types. The first one is known as metal access defect. And the next one is known as metal deficiency defect. Metal access defect is of two types. It means the first one is metal access defect. Due to an ionic vacancy. And the next one is metal access defect. Due to presence of extra cation. We have discussed imperfection in solid. Imperfection is also termed as defect. The imperfection is of two types, point defect and line defect. Point defect means if in a crystalline lattice, an atom or a point is missing from its ideal arrangement, then it is termed as point defect. But if there is disturbance in the arrangement of the entire row, if the entire row is disturbed, then it is termed as line defect. Point defect is categorized into cytometric, and the next one is known as non-cytometric. Cytometric means, in this case, the proportion of the element is maintained. It means the ratio of the element is maintained. Whereas in case of non-cytometric defect, the ratio of the element is not maintained. Cytometric defect, it is of based on the solids in which they are occurring. They are categorized into molecular solids and the next one is in ionic solid. In molecular solid, it is of vacancy defect. Vacancy means if certain ions are missing from the lattice point, it is termed as vacancy defect. Whereas in case of interstitial, it means if certain ions occupy the interstitial spaces between the atoms, that is termed as interstitial defect. When we discuss about the ionic solid, Frankel defect, this is also known as dislocation. It means an atom is missing from its lattice point and occupy the interstitial space in case of ionic solid. It means in case of Frankel defect, an atom is dislocated from its lattice point and occupy the interstitial site. It means it includes the both vacancy together with the interstitial defect, but in ionic solid. To the next, in this case, the electrical neutrality is maintained. In case of Schottky defect, equal number of anions and cations are missing from the lattice point and maintain the electrical neutrality. This is termed as Schottky defect. We will discuss non-cytometric defect. Non-cytometric defect is of two types: metal excess defect and metal deficiency defect. Metal excess defect, in that case, and it contains the extra metal ion. So the next one, if we discuss about the metal deficiency defect, in case of iron oxide, certain sites of Fe2 plus is displaced by Fe3 plus. It means if we are going to displace 3 Fe2 plus ion, then it will be displaced only by 2 Fe3 plus ion. In this way, we see that there is decrease in the number of iron atoms. This is termed as metal deficiency defect. So the next, we will discuss metal excess defect due to anionic vacancy. We will see this also creates color. It is termed as farbagender and imparts color to the metallic surfaces. So the next, metal deficiency defect due to presence of extra cation. It means on hitting the metallic surfaces, this type of defect is arises. We will take the example of zinc oxide. Later on, we will discuss it one by one. What is left? The next one is known as impurity defect. In that case, the electrical neutrality is maintained. It means in all this defect which we are discussing, in ionic solid, in non-cytometric defect, in impurity defect, the electrical neutrality is maintained. Only in case of non-cytometric defect, the elemental ratio is not maintained. It means if we are discussing about the iron oxide, that is FeO. But due to metal deficiency defect, it becomes Fe 0.980. Then what we see here? Here the ratio is not maintained. It means in this defect, the ratio of iron and oxygen is not maintained. That's why it is termed as non-cytometric defect. Whereas, remember one thing, that in all the defect, the electrical neutrality is maintained. Let us discuss the impurity defect. In case of impurity defect, during crystallization of sodium chloride, if it contains certain divalent impurity, then in that case,